Welcome to the Data Exchange with Ben Lorica, presented by Gradient Flow.
So, Chris Wiggins, faculty member at Columbia University and chief data scientist at the New York Times. Welcome to the Data Exchange podcast.
Thanks, Ben.
And so I know that you started out as a physicist. So by way of background, how did you go from being a physicist to being a machine learning professor?
Well, I had the benefit that when I was in high school, James Gleick's book on chaos came out.
Yeah.
And for me, that was very inspiring, the idea that you really push the limits of mathematical modeling by trying to model really complex systems in nature. And so as an undergraduate and then as a graduate student, the particular thing that I was really interested in is how do you study complexity in nature in general, in biology in particular. So my relationship with data was really forged by trying to apply the mindset of physics to the complexity of biology. So I did a PhD doing biological physics, trying to apply mathematical and physical models to biology. And it was during my PhD that biology became a data science, I would argue. So with the sequencing of the genome of freely living organisms, the relationship between biology and numbers really changed. And I think apart from the intellectual transition, there was sort of a people transition. There was a change in mindset where biologists suddenly became much more interested in theoretical and computational modeling, at least the biologists I was hanging out with. So when I showed up at graduate school in '93, modeling was sort of a curiosity, it's sort of, as long as it didn't get in the way of real biology and people pipetting. But by the time I finished my PhD, biologists were writing these perspectives pieces about how it was clear to them that they really needed to collaborate with technologists, people who knew how to make sense of large data sets.
So when did you start going to computer science conferences? So was that after grad school?
Let's see. I went so first I started going to computational biology conferences. I remember ISMB 2002 made a dent in my worldview. I went to NeurIPS in 2003, the workshops and the main conference. That definitely made a dent in my understanding of reality.
So 2003, Chris, this really is years before the reappearance of deep learning. So what was fashionable then?
Kernels.
Right?
So, learning often involves finding the best model, and best means you're going to be doing some optimization. And I mean, the things that were ascendant at the time that I started my or that sort of transition in my relationship with data was problems where you knew you could do the optimization. You knew that you could find the best model. And so I don't know how much of a technical rabbit hole we want to go down, but it was a very exciting time to think there's a set of problems in learning where when you frame the problem a particular way, you know that you will find the best model. So that was a very exciting time and really challenging to think about, over here is optimization and over here is natural science, right? And there was a broad class of problems that people were interested in where the optimization problem was really well solved, and we were really leveraging optimization techniques from the 50s and 60s. And it was sort of a field day to think about, sweet, how can we take the way we would want to represent the problem as understood from natural science and leverage these optimization techniques and learn the best model. It sort of gives you the sense that the truth is out there.
Yeah, I mean, I actually remember when support vector machines came out. It was super exciting, and at least at the time, it felt like you could tackle problems with a lot of dimensions compared to what happened before, right?
Yeah, so optimization at that point was so well advanced that it was a fearless time in terms of high dimensionality and number of examples. There's real sense that you could really scale up to large number of features and large number of examples. It was fun.
Yeah. And so it sounds like you've always been more into applying ML and data science type of techniques,
Absolutely.
as opposed
Absolutely.
to getting into the weeds of the theory. And although you do that too, right?
I mean, there are times,
you,
the times where I've really been interested in theory are times when I saw a connection between something really fun in physics that was underexplored in the machine learning community and machine learning applications. So some of my papers are about taking ideas from theoretical physics, some of which are from like the 30s, and trying to find new ways to apply them in problems in machine learning, particularly problems in machine learning where probability is the object you work with, right? There are many problems, support vector machines being an example, where you write down a loss function and then the excitement is, can you do that optimization? There are other problems where you really want to, or where scientists really want a probabilistic model, an interpretable model, often called, often generative models or graphical models is a nice sort of visual shorthand for giving you a sense that you understand what's happening. And those are the problems for which techniques in developed mostly in theoretical physics, for example, in approximating posterior distributions or what have you, can be really useful for advancing and suggesting new theoretical methods in machine learning.
So
but you're right. Most of my interest has been in the sort of craziness of taking something as abstract as a model and as complex as a real world data set and finding the audacity of hope that you can take this theoretical method and apply it to this messy real world problem.
So as you were talking there, I was reminded we actually have a mutual friend, Ben Recht.
Of course, yes.
Yeah. Who actually also started out in kind of this kernel methods, and then he went into compressed sensing.
Yep.
And then he actually wrote a series of kind of general explainers for reinforcement learning, where he credited you with one of his diagrams. I don't know if you saw that.
I forgot about that. Yeah.
It was pretty interesting. So reinforcement learning is another one of these topics that has been around for a while, but now is super hot again. So what's your history or personal experience with reinforcement learning, if any?
So I think what Ben touches on, and Michael Jordan's been saying this too in a different language, is that there's a set of problems in statistics that come from science, like when Fisher was interested in what is true. And there's a set of problems in nature that come from trying to make decisions. And a lot of this really was born of World War II, sequential decision making, it used to be called, about real problems where you're not interested in what's true, you're interested in what's the best thing to do. And those problems also show up in healthcare, robotics, and industry. So in industry, you're often not interested in knowing like how bad is the blue button. You just want to know, should I show the blue button or the green button? And should really comes from some other loss function. There's some reward you're trying to optimize over the space of possible options, actions, I should say. And you, in order to really know that, you really have to explore and exploit. You really have to try out different actions and then learn what's the best action. So there's a community, the machine learning community has, sort of rediscovered this as the way the machine learning community sometimes does.
Thanks.
And done a great job, doing a good job at it. That said, the point of Ben's writing is there is a literature in which this was known, for example, control theory, or under an early word, cybernetics, right. Of course, coming from the word for control, right? There, people in World War II and even before were thinking about how can I use mathematics to make decisions. It's happening more in industry for a variety of reasons, including that, hardware and software is getting real good and machine learning is getting real good. But also there's just sort of a general acceptance in fields, that used to be not so quantitative, that we should be able to use machine learning to help us make difficult decisions, whether that's health or marketing or, design or other problems that seemed like, there was no data involved and no fancy math. Now there's sort of more communities who are expecting machine learning to help them make difficult decisions.
Yeah, and it seems like that the people who were pure into deep reinforcement learning, at least some of the roboticists, are beginning to realize that if we have some domain knowledge, maybe we should use it. So now they're starting to talk about this hybrid between deep reinforcement learning and using a little bit of control theory, and it seems like in many ways it makes a lot of sense. If you know something about the subject, you should use it, right?
You would hope. I mean, that's been an interesting narrative. Actually, even before deep learning, I can
Yeah.
remember talking to people. I was talking to Jeremy Howard about this in 2012 or so. Like, he was really kind of amazed that in Kaggle, the winning teams were using random forests or something, and just had no. Often the winning Kagglers had no domain expertise, and that was sort of mystifying that you could just take a bunch of features and throw it into machine learning and get really good results. This is obviously even more true now with deep learning. For my mind, a pivotal paper was the paper by DeepMind before they became Google DeepMind, if I remember correctly, where they just took a bunch of Atari games and the features were the raw pixels. Right. And they managed to get human level performance, as the paper said. This was a Nature paper in spring of 2015, just using deep learning. My interest in it came originally from health. So even, I think in 2012, I started writing grant proposals to NSF and NIH about trying to take what had been some work that colleagues of mine from Columbia Medical School had been doing and trying to apply very interpretable generative models to electronic health records and ask, is there a sequential decision optimization mindset that could be useful to healthcare professionals or doctors for trying to learn, like, what is the right best next thing to do? Fortunately, that was funded by NSF. Actually, it was an NSF NIH collaboration, and thereafter, a totally different input was coming from the New York Times. So via my work at the New York Times, it was clear that there were many problems where people thought that what they wanted was a method that would predict outcome in the absence of treatment. But what they really wanted was to know what was the optimal treatment in order to get that outcome. And this, I think, has been true for supervised learning since the 19th century. So back in 1899, when Udny Yule wrote a paper about the causes of poverty in England, he did it by doing ordinary least squares with a couple of variables. But what he really wanted to know was a policy statement. What should we do in order to presumably decrease, for Udny Yule's interest, poverty in England? So there's a long history of trying to build a predictive model from observational data, but what you really want is to know what's the optimal treatment. That's really how I started. That was another sort of entry into reinforcement learning, was, in addition to the health context, the industrial context, where you really just want to know how to make the right decision. It's very difficult to do that if all you have is data where you haven't done an intervention.
So what's your sense of reinforcement learning, let's say in the next 5 years? Because right now it seems like it's mostly used by researchers. It's not as accessible to practitioners and developers. So, for example, one area, Chris, that I'm starting to see applications for reinforcement learning is personalization and recommendation systems. But then when I took a deep dive, I realized, a lot of this is people in these big tech companies like Google, Facebook, Chinese tech companies. They publish papers, but there's no code and there's no tutorials, there's no how-tos, so it makes it harder for the regular person to do it, because to do let's say recommenders for reinforcement learning for recommenders, you have to use log files and do some kind of offline training of some kind, right? So how do you think there will come a point where a lot of these becomes more accessible? So
yes.
we need people like you to develop tutorials.
Okay. Well, so there's a lot to unpack in what you just said there.
Yeah.
So doing reinforcement learning doesn't require you to have fancy deep neural networks, right?
Right.
John Miles Wright, for example, wrote this. I think it was an O'Reilly book years ago on
bandits.
Exactly, right. And he said, like, look, you can do epsilon greedy optimization. That's a very simple bandit. Doesn't take a lot of math, right? The challenge.
Yeah, I agree. So bandits, I think that bandits are kind of the entry point, but then
that's exactly right.
But then now you're starting to hear people using, like, at YouTube, doing some deep RL as part of the recommender, right? So not
absolutely right. So at the scale.
They didn't throw out
At the scale of Google or Baidu or Google.
Yeah.
You can do almost anything. Remember, though, that there's a big difference between what is done and what is published. So
Right.
the distribution of things that are published is not necessarily equal to the distribution of things that are done, right? It's just that, like, when it turns out that the right tool for the right job is drawing a histogram, you don't publish a paper about it. So, the things that are being published on are not necessarily things that get the job done. Jay Krebs had a tweet that was so good that I kept it bookmarked for a long time. If the trick to productionalizing things is often to look at page 4 of the papers, see what's the dumb thing that they all compare against, and then implement that. And also, the challenge of using, say, epsilon greedy in production is not the math, right? It's the systems integration. It's all the work that has to be done around the tech nugget. If you go look at this nice review article from 2015 by Michael Jordan and Tom Mitchell, they talk about how machine learning in production. So I think it's Jordan who draws this little stack of the Berkeley Ample Labs conception of machine learning systems. And the actual machine learning is just one nugget, right? There's still the whole stack of, like, getting your hands on the data, deploying the data, monitoring how the eventual product is working. Right? The machine learning thing is just like one little nugget within the whole technical system. And of course, these technical systems are themselves only a small part of sociotechnical systems. Remember that. So the rate limiting step is not whether or not you can do the fancy deep RL. And you were right that, like, 2 or 3 years ago, there wasn't a lot of open source code for doing the fancy stuff. Truth is, though, Google now, even like Uber Labs, Microsoft,
Rice Lab with Ray.
A lot of these teams, right? So Chris Ray, right? So a lot of these teams and companies are distributing a lot of pretty good software packages. So you go to GitHub, download your favorite repo. John Langford has been doing this for a year with Vocal Rabbit. There's a lot of repos coming from. There's a lot of code bases coming from industry now that people can leverage if you want to do something fancy. But first do the simple thing.
The open source project from Berkeley, RLlib, is now on Amazon and more recently Azure. So, like I said, so the libraries are there. Now we need tutorials for developers.
Okay.
Just like we needed tutorials for how to build your first computer vision application. So we need something like that for RL, I think. But the term data science, right? So I was in Silicon Valley when we first started talking about this term, and originally it was supposed to describe someone who was nimble, who could cut across to visualization, data prep, a little bit of modeling. But then now, fast forward to today, it seems like it only refers to modeling, right? So do you remember there was a thesis by Ben Fry, what's this, I forget, he drew this diagram. He didn't call it data science, but it communicated the same thing, which is basically someone who did a little bit of stats, a little bit of this, a little bit of prep, some ML. Okay. But now, fast forward to today, I look at the curriculum of data science in the different universities. It seems like it's all modeling, right? Am I wrong?
So there's two things to organize two things that have organized my thoughts. One is canonical documents, right? So I'm an academic, so I like to look at original documents and see the way people described it when they published, which is why I value publishing. And the other is job descriptions in industry.
Right.
And so for me, some of the canonical documents of data science are Jeff Hammerbacher's single paragraph describing why they made the job description data scientist. And he wrote this in 2009 in the book Beautiful Data. I think also an O'Reilly publication.
Before the best minds of our generation.
It was around that time that Jeff said that. He started a trend of people who left Facebook and then said, "Oh, what Facebook doing is bad." So that's another story. And Bill Cleveland's 2001 article called Data Science. So Bill Cleveland at Bell Labs, AT&T Bell Labs, had this paper in 2001 addressed at academic statistics departments saying we should create a new subfield within the field of statistics called data science. So those are two documents that I look at that I consider,
So
canon.
there's another one that I'll throw in there. Ben Fry's thesis, MIT Media Lab. He wrote the visualization tool processing.
Yep.
And then he had, like I said, he had these different disciplines. It wasn't a Venn diagram. It was more like drawn like a pipeline.
Yeah.
But he didn't use the term data science. But then I kind of look at that as the first document that described what we were seeing at that time, which was this person who was jumping around. Different.
So you've invoked Venn diagram twice. So I guess we should also capture Drew Conway's Venn diagram from 2010, I believe.
Yeah.
Portraying data science as this mixture of machine learning and domain expertise. So that is also a document that rattles in my head when I think about what is data science. So to get to your point, which is data science has become just the modeling part.
Yeah.
I do think if you look at Jeff Hammerbacher's description from 2009, he said, we created this job title because, statistician and business analyst didn't cut it. Somebody in our group might be building a data processing pipeline in Python, doing a regression or an A/B test in R, and communicating the results clearly and concisely to the rest of the organization. So communicating the results in a clear and concise fashion to the rest of the organization. So I like that paragraph because the data processing has largely been given to data engineers.
Yes. Yeah.
The modeling still is often for a data science group, at least in the New York Times, where data scientists still mean what it did, I would argue, from like the 2010 definition of data scientist. And a lot of the things that Jeff describes in that paragraph are now done by a much larger group, which at New York Times is called the data analysts. So at the Times, there are separate groups in data engineering, data science, data analysts, data governance, and all of these things, I think, have been at various times and companies called data science. So for example, at Facebook, they did, I think, a real disservice to language by relabeling all of the data analysts to be data scientists one day, which is why
LinkedIn did this too, in the sense of they had two types of data scientists: the ones that were data analysts, and then the ones that were more of what we think of as data scientists. And and when I complained to some of them, I said, it's confusing for us on the outside to tell which is which. He said, well, the data analyst people wanted the title, so we gave it to them.
So, right. So, so I recognize there's all sorts of human and political forces here, but just for like having words matter, it creates a lot of confusion. Similarly, Lyft had to sort of escalate to keep up. At the New York Times, we still consider data science to be developing and deploying machine learning applications for
let me ask you this. Does a data scientist at the New York Times write their own data pipeline?
Sometimes.
Yeah.
Definitely sometimes.
So I'm starting to hear
and sometimes we write and deploy our own APIs, but if it really has to be bulletproof, we're fortunate to be able to work alongside really good software engineers. And there's certainly a lot of like pulling of data and exploring of data, but we're fortunate to work alongside really good data analysts who really understand the pathologies of the data, and we have really good partnerships with the data engineers, with the data scientists, with the data analysts, with the software engineers.
So am I mischaracterizing it, Chris, when I say that if you look at data science programs at universities, they tend to emphasize more of the modeling?
It's hard for me to speak about all university programs. There's such a proliferation of programs right now. Certainly, I was on the education committee back in 2012 at the Data Science Institute at Columbia, and certainly when we set it up then, yes, it was about machine learning and probability and statistics were forefront, as was understanding a bit about databases and algorithms. But as far as what goes on at different universities, there's a wide variety of things that are being taught under the name data science. The sort of entropy of that idea space, though, I think is still smaller than the entropy of job descriptions. So job descriptions under the title data science is broad and dynamic.
Right. Which means that when you evaluate someone who just comes out of school as a fresh data scientist, say at the New York Times, I don't know if you folks hire fresh graduates, what are you looking for?
So a set of professional skills as well as machine learning skills. So in terms of machine learning, we do sometimes hire people fresh out of PhD programs. I don't know that we've hired anybody straight out of a master's or more junior position, at least in our group. In terms of machine learning skills, I'd like to see evidence that people have a breadth in machine learning so they know the right tool for the right job. So for example, if somebody comes out of a program where they've just done, I don't know, just deep learning or something, or just NLP, that's kind of difficult because we solve a wide variety of problems. Similarly, it's nice to see some evidence that they understand the problem deeply enough that they know how to extend the problem if necessary. You know, scikit-learn is great, but not every problem you're going to encounter in your life is already solved by import scikit-learn. So that sort of breadth and depth in machine learning is something we look for. However, that's not all of it. I really like the last sentence of Jeff Hammerbacher's paragraph. Explains communicate the results to everybody in a clear, concise. Absolutely, we have not hired people because of their communication abilities. There's definitely candidates we were like, man, this person is real good, technically good, knows machine learning, good software skills, systems mindset, can't communicate, we're not going to hire this person. So I absolutely want people that I can put in a room with a non-technologist and know that they're going to be able to listen to them and understand what they need. And then once they actually execute some machine learning, be able to communicate it back to them in a way that they can put to work. So I need some collaboration skills in addition to the technical skills, at least for data science at the Times.
So it sounds like in the New York Times, you folks have more of a centralized team where you have a team of data scientists and technologists working under you, and then they go out and work with journalists and other parts of the organization, right? So then
I mean, to be clear, it's mostly other parts of the organization other than the journalists. So it's really, on the newsroom side, it's really more so editors than journalists, right? Because the things we do are slow. The journalists, they have to meet deadlines, right? And they have, a particular type of pressures. With editors, we can work on things like how do we improve process generally. But the editors are only one numerically small set of the stakeholders. There's also a very large set of business stakeholders for whom they really do have optimization problems. Right? They have problems where they want to hit a number. That number sometimes has units of US dollars. And those are problems that are very easy to reframe as machine learning tasks. Right? The craft of journalism is often not easily reframed as a machine learning task.
Right. So many of the projects you work on are business problems, not things that we come across while reading the New York Times.
Yeah, the newsroom-facing things involve editorial process, sometimes giving strategic and software support to people who think about the craft of audience development, which is sort of how a story gets promoted, or recommendation engines, as you mentioned earlier, is one that's definitely consumer-facing, and that's part of our team's work is algorithmic recommendations. But many of the problems are relevant to marketing or advertising or distributing copies of the newspaper, right? There's still, people who buy single copies of the newspaper, a wide variety of business side problems, in addition to the ones that you would think of as a newspaper.
So what's your advice to someone who wants to get a job at the New York Times in your team?
And so, as I said, so it helps to know, in terms of languages, SQL and scikit. So SQL, it helps to have enough familiarity with SQL that you understand that nobody's going to hand you a CSV. You're gonna have to
by the way, surprisingly, some developers who are great programmers struggle with SQL because the set theory, I think, is a bit confusing to them.
Okay. I've seen that. So we've been fortunate that the people who've been hired have been able to pick up SQL pretty quick, even when it's coming straight out of PhD programs. Yeah. And scikit, meaning a lot of what we do starts with scikit-learn. It's a very useful first go at any problem is to see, okay, well, what can we do just to model.fit of this thing? So it's a great first sort of tool to open up a problem. But that's just the languages. Separately is the machine learning. So as I said, a sufficient breadth that you're good at knowing the right tool for the right job, sufficient depth that you understand complexity control and not overfitting data, or that you know how to extend beyond what's in scikit for a new use case. And then there's the collaboration skills, which include primarily communication. I really do think communication is absolutely central for what we hired for.
Which means what? Visualization, PowerPoint.
Sitting in a room with a human being. So like you're sitting in a room with a human being who does not know calculus, does not
You'll have
know
to show
or
them
loss
charts.
function.
You'll have to show them charts, right? Or something.
No, way before you get to the chart, you have to listen to their problem and understand
Right.
what they want.
Right.
So actually understanding what a person wants, right? That's not about how good your chart making is going to be in 5 weeks.
Right.
That's about like in the first couple hours, in the first meeting or two, like, can you figure out like what is this person's goal? You know, what is their team goal? What objectives are they trying to hit? What are the dynamics in their part of the org? You know, is this a problem that needs to be solved in 24 hours, or is going to be a strategic problem of use for the next couple of quarters or a couple of years, or the future of the company is going to pivot in that direction? Those communication things, are really super important, and at least in my group, that's what we're hiring for.
And that's not something you learn in a PhD program, though, Chris.
It absolutely is if you have a multidisciplinary PhD training. So again, I've everyone's biased by their own randomness of their trajectories, but I spent a lot of time hanging out with biologists in graduate school, and that was absolutely, I think, training for talking to people who's got a very different definition of mission accomplished, right? They have a clear model of the world. Their model is written in a language other than the language in which your model of the world is built. You're both right, and then you have this interesting trading zone where you're using tools and artifacts in one way, they're using different tools, sometimes the same tools, but used in very different ways, and you manage to construct value together collaboratively. So that's sort of it's different from peer review. It's like complementary review. Like, are you able to work with somebody who's got a different worldview, a different tool set, and create something of value together? If that's your PhD program, I think that's definitely a good training for it. PhD programs where you just hang out with people who are just like you, and you push the envelope of what's known in that particular subfield, I think that's less useful in data science. Perhaps it's very useful in machine learning, but less so in the thing where you're trying to work with somebody who comes from a domain expertise, and you're trying to advance problems from that domain with machine learning, which is why I like Drew Conway's Venn diagram.
Right. So let's close with some prognostication and opining about the future. So obviously we can talk about AI in general and what's happening there, but one area, Chris, actually, that I think we share a lot of mutual interest is the rise of interest in ethics, security, privacy, fairness, bias, safety, reliability. So it started out with academics having conferences, but now industry people are coming out with tools and courses and things like this. But my sense, Chris, I don't know how you feel, is at the end of the day, there's no checklist that will guard you for anything, right? It's ethics after all, right? So what you need is a complete different mindset of, as you say, probably developing better listening skills, number one, embracing diversity in your team, not just from cultural diversity, but also diversity of backgrounds. Right, so having a team that maybe someone on your team is a security person, or someone on your team is a lawyer, or whatever, right? So not everything is machine learning or technology, right? So
that's why I invoked the phrase sociotechnical systems. And again, actually, if you look at this review article from Jordan and Mitchell from 2015, there's a lot in there about that. I'm pretty sure the word ethics actually appears in that review article. It's in some ways you can see that it's already there, at least for those two authors, the realization that this machine learning is being deployed, right? And it's being deployed with power, and as Spider-Man taught us, with power comes responsibility. I think there's a lot of ways to train the future generation here. Machine learning is being deployed in high-stakes situations. To rip off a title of a paper by Cynthia Rudin on this. So there's of interest in the internal collaborators, right? When you're in a company and you're working with somebody, they're going to want to understand what it's doing, and they're going to want to understand how it can go wrong in the future. This is true in dynamic environments like the news, right? Your language model is going to change from quarter to quarter as the valence of different words changes, as the world changes. There is growing collective action. Companies like Facebook or the New York Times are full of employees who are letting their managers and leaders know when something is done that they don't think is coherent with the stated values of the company. I think for the better, and Google and other companies as well. There's collective action happening at lots of companies right now. How are you going to think about it as a technologist? Well, I don't think the right action is to say, let's make a tech fix for this, and then there'll be an API for fairness. I don't think the right action is to say, that's not my department. Somebody else is going to handle it, in part because nobody is going to understand the technology as well as people who built the technology. Right? So I do think there's going to have to be a humility to go and learn from other communities what's already been done. That's often not the mindset of many people in the sciences. I come from physics, and a lot of physicists are write-only physicists. They don't read a lot of papers, come from other literatures. They like to invent things themselves. And ethics is a good example where, like in the 70s, people worked really hard to define and operationalize ethics in the human subject research community. There's a lot of work there that we can leverage and learn from. It doesn't have to be invented anew right now. So there's growing desire to even define and design for ethics in corporations. And I definitely see it in my classes. So in 2015, I sat down with the history professor and we said, okay, let's teach a class on the history of data science. And as we started teaching the class in spring of 2017 rather, it rapidly became clear that what the students really want to understand was the ethical applications. And that class has now become a class on the history and ethics of data, really driven by student interest. Similarly, I co-founded this nonprofit 10 years ago that's really a summer internship program for students in startups. So front-end, back-end, data science design students. And that alumni group, because as the program goes on, there now is a cohort of alumni who have gone through that program. They also have really driven that program to be much more about the social impact of software engineering and data science. So the programming and the values of that community have much more tended to thinking about what is the impact of what we do? How do we even think about that? Fortunately, it's not, I wouldn't say that it's a solved problem, but fortunately there are giants on whose shoulders you can stand. And also there's an incredibly growing literature in it. I'm having 2 or 3 conversations a day with young people about where do I learn about, as one person put it to me yesterday, the ethics of the internet. Or I'm in a Slack conversation with somebody now about what books should I give my managers so that they understand that there's it matters what product design decisions we're making now, and that on a large platform company, young people actually are deriving change because they actually want to build something where they know they can sleep at night.
Right. No, I mean, I think what you described is happening, but still unusual, where you actually collaborate and design a course with someone from
that's very unusual.
Social sciences or humanities, right? Because tech people, they always seem to, I don't know, either they hire people from the same companies again and again, or they only look at certain schools. Let alone, looking at people in other disciplines, right? So, I mean, I think that
those are 2 absolute pathologies. Another pathology is thinking that everything is a tech problem.
Yeah,
is thinking that we have this problem. How can we product our way out of it, or how do we algorithm our way out of it, or how do we modify the loss function to make it better?
Or if we only had enough data, we can overcome, right?
And I think that's the value even of the word sociotechnological system, is just realizing that your tech nugget is pretty cool, but it's only a small part of a larger system. So and I don't think it's insurmountable. I don't think technologists should just be that's too hard, I'm gonna throw up my hands, or only people not like me think about that kind of stuff. I don't think that's an option anymore.
So you've been in machine learning for a long time. So what's your reaction to this ever increasing arms race now in language models, right? So where I think the last model from OpenAI has 175 billion parameters. So good luck replicating or training that model from scratch, right? So God knows how much money that will cost. So now the field is evolving into this complete arms race, where very few companies have the resources to actually compete, let alone universities, right? So do you think I'm secretly still holding out that someone will come up with something to just disrupt the whole the whole area of machine learning.
So arms race is a very interesting phrase for many reasons. One of which is, if you think about the original arms race, or the arms race that causes us all to use that phrase, it's like, how many megatons can you put in a warhead?
Right.
So there was an escalation between two superpowers, and there was a particular KPI that they were interested in optimizing. And every year somebody would come up with a new thing that optimized that KPI, megatons of destruction. Right. At some point, with many arms races, the community comes to realize that that single KPI is not actually relevant to whatever the larger goal is. It is not the case that the world has been made safe for democracy because somebody optimized that KPI relative to somebody else, right? And it's not the case now that we're going to megaton our way out of the problem. It's ludicrous. People don't even remember now what people were optimizing for, unless you're old. So similarly, with language models or anything else, there's some KPI that's being optimized. And at some point, you've done such a good job optimizing that KPI that it is no longer the rate limiting KPI. Right. And you realize that actually, if you really want to solve the problem now, or if you want to solve your way out of the problems that the market or the world or the sociotechnological system is imposing on you now, it's not actually making that KPI better. That's where you need to spend your energies. I mean, a lot of arms races, make themselves redundant by getting that KPI to be so good that it's no longer the KPI that people even care about. So it's not the KPIs. It's not that arms races somehow will be won, or even that like we should be focusing our attention is who's going to drive that KPI more. Rather, at some point, like let's say deep learning, once it just makes like function approximation a solved problem, then people start saying, okay, let's assume that function approximation is solved. What is it that doesn't solve, right? And so people who are investigating causality, right, are now pointing out to people like you don't actually find causal models by having awesome cat face science, right? The science of figuring out whether the picture is a cat face or a dog face.
Right.
You could just crush that problem. Wouldn't necessarily help you with causal problems, right? Wouldn't necessarily help you with ethics or policy problems. There's, I guess, arms race is an interesting phrase to use because there are many problems in the world where you. Please.
It's reminiscent of what happens in other disciplines too, in the sense that when in order to stay kind of at the cutting edge or somewhat relevant, you have to kind of play the game the way it's being played. So in other words, if you think of machine learning as being kind of a search problem where you're searching through the space of functions, everyone is searching in the same corner. No one is searching over here or here, right? So
yeah, but the world is always more complicated than that, right? When somebody builds a technology that just crushes it on that technology, there's always plenty of ways to move around that goal. I mean, arms race being an example, having the biggest bombers won't help you if you're fighting an asymmetric war, or if somebody just wins by not playing your game.
But funding or getting hired or something like that is dependent on you being over here where everyone else is, right? So if you're over here, you might not get the funding you need, right? So
if you want to go into an overcrowded field, machine learning today and the way that people have to look at the archive and try to see if their PhD thesis has just been overtaken by a superior technology actually reminds me a lot of what I saw in theoretical physics in the 1990s. Yeah. So in 1990s in theoretical physics, now called the second string revolution,
right.
It was in graduate school at Princeton. It was a very stressful time for the graduate students there, checking the archive every day to see if their PhD thesis had just been made redundant. There's a similar anxiety, I think, now for all the graduate students who are trying to go at, one or two extremely competitive, overcrowded fields. But the world is a big place. There's lots of problems. Right? You don't necessarily have to put your force against the strong point. Sometimes the right way to do it is to think different, or put your strength against the weak point and find what are the under attacked problems.
Or as you alluded to earlier, talk with people from other disciplines.
Yeah. I mean, that's one entirely different way to advance knowledge, is to find connections that haven't been made before. I don't know. I've always found those the interesting ones, in part because I like people. And so a lot of times the problems that are interesting to solve are the problems where there's a whole group of people who have a set of problems that, you know, you could address if you could just figure out how to take these tools from this community and use them to advance, to solve problems from that other community, like machine learning in biology, or now machine learning in physics, or machine learning in other fields.
Right.
You know, I think that's been interesting, is to find, you know, people from another community, who, particularly individuals who can serve as a culture broker between two different communities. And that's how you build new fields.
Right. And with that, thank you, Chris.
Sure.
This is a long time coming, and thank you for spending the time with me.
Of course. Nice chatting with you.